Alright, so what I'd like to talk about in this video is a continuation of the time domain thermoreflectance short course from fundamentals to operational details. In this series of videos, what I'd like to discuss is the time domain thermoreflectance hardware, alternatively titled, What is all this stuff? As you'll see in a second, there's a lot of optics, electronics, mechanical stuff involved in doing a TDTR experiment. And I'd like to just walk you through what all of this stuff is and what the basic design criteria, or at least the selection criteria for these things are. There's a very wide variety of hardware in use for different groups around the world, and I'll just give you a basic idea of how they go about choosing what they do. Note that if you don't have a very strong background in optics, I really recommend that you watch some of the other videos that I've made first. I guess at the moment I'm calling them the fundamentals of optics lessons or the preliminary material. These things will explain the details of some of the components. And at an absolute bare minimum, it's really important to understand the concept of laser polarization for linearly polarized beams, and to understand how basic optics work, like a polarizing beam splitter and a half wave plate. If you don't understand those things, you're probably going to have a difficult time understanding how this stuff works. All right, so with that being said, I'm going to talk about a couple of different layouts for time domain thermoreflectance systems and why some of the components exist in these systems. But before I even do that, I have to say that there are at least two different types of main time domain thermoreflectance systems in use. One of them I'll call a two-tint time domain thermoreflectance system, which is really just a two-polarization system where all of the pump beam and the probe beam are essentially divided by a combination of polarization primarily and partially by wavelength. But in the case of a two-tint time domain thermoreflectance system, the pump and the probe wavelength are very, very similar to one another, if not exactly the same. In the other variant of system, called a two-color time domain thermoreflectance system, essentially right away what the user does is they generate a high energy, usually it's a pump beam. So you use your laser, which is usually an 800 nanometer pulse laser, to generate a 400 nanometer wavelength laser. And then when you're working with your pump and probe beam, dividing them and combining them, you do that all based on the color of the beams at that point. So I'll talk about both of these systems in a lot of detail, both about like what exactly this two-tint and two colors means. But for the moment, I'm going to walk through the layout of a two-tint time domain thermoreflectance system, and then I'll come back to the two-color time domain thermoreflectance system. In general, historically, the two-tint time domain thermoreflectance system was invented first, I would argue, and then the two-color variant of time domain thermoreflectance came along just a little bit later, and also has about equally wide usage. So I'll try and cover both of these systems, but for the moment I'm going to walk through how a two-tint time domain thermoreflectance system works.